we've looked at this exponential growth and decay model before. Today we're going to do 4 word problems, and what's going to be a challenge for you with these word problems is figuring out the steps to solving it with the unknown changing. So, like for growth, you have the initial amount here times 1 plus the rate. Remember, this is like a percentage. It needs to be converted to a decimal. So, like if you invested money at 5%, I would put 0.05 here. And you wanted to calculate how much money you'll have in 10 years, you would put a 10 up here. So, in our word problems today, they're not going to just ask you necessarily like, how much money will you have in 10 years? It might say, after 10 years, you've earned $12,000. What was the interest rate? So maybe you have to solve for rate. Or it could say, you've had money invested for 15 years at an interest rate of 3%, and you now have $20,000. How much money did you start with? Okay. Or maybe it could say, you have $3,000 now, and you want to invest it at 5%. In how many years will you have $8,000? So in that problem, you're trying to solve for time, number of years. Okay, so you have to really read the word problem, use critical thinking to figure out which part is unknown. Maybe it's the final amount, the initial amount, maybe it's the rate, or maybe it's the time. And then you have to use the right math strategy to actually solve for that unknown. Okay, that's the challenge. So we're going to do 4 problems, and there's 3 different strategies within those 4 problems. All right, we'll start out with an easier problem. This is one similar to what you've done before, so I'd like you to just try this one. You do need a calculator. There was one similar to this on your Chapter 7 quiz, so this one isn't new to you. Just remembering that this is a little less than that 3rd period. Got kind of sorted out on you. So you have to memorize the model. Okay, so growth rate changes, right? So for real growth rate problems, there is going to be like a time frame, like 2000 to 2010. I was just looking at growth rate like for COVID, and when it came out, they were saying it has this exponential growth rate, and it did within like the first 8 months, and then it fell for a bit, and then it grew exponentially again, and then it fell for a bit, and now it's falling. Depending on whose data you look at. So you could do like an exponential model for COVID between like the first 8 months. And then after that, the data doesn't look like exponential data. It looks different. So, for real math that scientists do, there's usually like a time frame that they can model an equation off of. It's not usually like forever. Because in real life, the data changes. So, this is only between 2000 and 2010. The city had this population. Maybe after 2010, there was a change in jobs or change in policy that affected the population. So anyway, the city had 2.9 million people in 2000. So we're going to put that in for A. 2,950,000. 1 plus, and wow, it says it's an annual rate of decrease. So I'm going to be careful and do a minus sign. This is a decrease. So what does make a population decrease in a city? Any ideas, you guys? Yeah, maybe people are moving out because they're crime rate. Maybe there was a massive natural disaster and people are moving out because of that. No jobs. And maybe there's no jobs. So lots of things can make a city's population decrease. Happens in country towns a lot. People move to the city to get jobs. All right, so 8 years have gone by. So while this says this model is true between 2000 and 2010, we're figuring out the population in 2008. So 8 years have gone by. We're going to put an 8 up there for the exponent. That's the amount of time that has gone by. And you don't have to show any work. You can just put it in your calculator. What I do want is a complete sentence answer. Say a natural disaster as big as like Hurricane Katrina and New Orleans could make a population drop over a span of a few years. So my complete sentence answer will be in 2008, the population dropped to 2,409,123. With people, you generally round to the nearest whole number, round up. Pretty significant drop there. Anybody back my number up? Anybody do it? Feeling good? Okay, let's move on to number 2. Set up your formula, try to solve it. Oh. And I like these calculators. Yeah. So accountants, it's like people's entire careers calculating depreciation of equipment because you have to pay taxes on like items that your business owns. So if I have like $3 million worth of cars on my car lot, I have to pay taxes on that. It's my property. valuable property. But if I have $3 million worth of 2021 cars on my lot, then they're truly worth $3 million. But if it's 2024 and my cars are 2 years old, they're not worth that anymore. So I'm going to calculate that depreciation to tell the government, well, my cars aren't worth $3 million anymore. My cars are only worth $2.5 million. I'm not paying as much taxes. So accountants are actually really, really important for saving businesses money that way. There's lots of different ways that you can work numbers to save people money. So much of making money comes into taxes. Figuring out how to save money on taxes. Okay, I have a new car. It doesn't tell me how much my new car is worth. It's depreciating, so I use a minus sign. 11% each year. I'm going to have it for 5 years. Oh, after 5 years, my car is worth $2,315. So this is my end amount. This number should be plugged in for Y. It's not my initial amount. That's after time what my car is worth. So this time we're solving the unknown was how much was it originally worth? Wait a minute. Is this really worth what it's telling me it's worth? So order of operations, what I would do is just subtract and make the 0.89 to the fifth. And if I'm solving for A, you can go ahead and raise that to the fifth power. 2,315 equals A times, ooh, and it's a pretty big decimal. I hate to round it. 0.558, and now we'll just divide. Looks like this car lost like half its value in 5 years. Not too many cars you can buy anymore for $4,000. The car was bought for $4,145.73. Maybe you could buy a scooter for that. Can't buy cars for $4,000. Not for a really long time. I never bought a car for $4,000. New car, that is. Someone will sell you a used car for $4,000 if you got cash. Any questions on number 2? Here we go, number 3. It's about to get trickier right here. 3 and 4 are going to require a different strategy. I guess so. I've never been into watches. 0.05. Alright, so it's $1,200 watch. Never had a watch that much, so I don't know about watches gaining value. your parents are into this. 0.05. Lots of things do gain value. Okay, we don't know how many years. It says after how many years? The years